Every single day, we're all using technology that relies on this invisible infrastructure, orbiting hundreds of miles above our heads. From the maps on our phones to the entire global financial system, our world is literally woven together by a fragile network of signals from space. But what happens when that network breaks? To really understand just how vulnerable we are, we actually need to go back in time to a really strange day back in 1998.
So to get a handle on our vulnerability today, we've got to rewind the clock to a pretty wild case from 1998. This was a time when pagers, were the absolute peak of mobile communication. And it turns out one single failure way up in orbit sent this massive shockwave across the entire United States.
Picture this. It's a Tuesday, and all of a sudden, millions of pagers, for doctors on call, for business people, you name it, they just went dead silent. It wasn't some software bug or a problem on the ground. Nope. The problem was much, much higher up.
And what's crazy is just how fast everything went sideways. On May 19th, this company, PanAmSat, completely lost control of its Galaxy 4 communications satellite. And within hours, the dominoes just started to fall. Pagers died, yeah, but then credit card machines at gas stations stopped working. Even major news services like Reuters and NPR suddenly went off the air. It was a total communications blackout, all because of one single point of failure in space.
Okay, so you're probably thinking this had to be something huge, right? Like a collision with space junk, or maybe a massive solar flare zapped it. But the reality, well, it was way weirder and honestly a lot more unsettling. Get this. The culprit was something called tin whiskers. These are these tiny microscopic hair-like crystals that can literally grow out of pure tin solder over time. And engineers think one of these tiny little metallic hairs grew just long enough to create an electrical short inside the satellite's brain, basically, its control processor. And poof, it fried the whole thing. It is just an incredible example of how something so small you can't even see it could take down a multi-million-dollar piece of hardware and mess up life for millions of people. Okay, so that was 1998. The Galaxy IV thing was a real wake-up call, for sure. But honestly, it was just a little preview of the massive, absolutely critical system we all rely on today. Think about this. Since we first started launching rockets into space, we've put over 17,000 satellites up there. This huge and, let's be honest, mostly forgotten fleet forms this invisible infrastructure that now powers enormous parts of our modern lives. We're talking way, way beyond pagers. And that's the real kicker here. Our dependency has just exploded. What was a huge inconvenience back in 1998 would be a full-blown economic catastrophe today. And right at the heart of all this are the Global Navigation Satellite Systems, or GNSS. That includes systems you've definitely heard of, like America's GPS or Europe's Galileo. They're now absolutely essential for everything from financial markets and power grids to automated farming. So how does all this stuff actually work? I mean, how do we get from a satellite way up there to a useful application right here on the ground? It's usually broken down into what's called the space value chain.
It's actually pretty simple when you break it down. Upstream is all the hardware stuff, designing, building, and launching the satellites. Midstream is about wrangling all the raw data they beam down, processing it, storing it, and getting it ready. And then downstream, well, that's where the magic really happens for us. That's turning all that data into the apps and services we use every single day. And this, right here, this is a perfect example of that downstream part in action. This isn't just a pretty picture of our planet, it's an incredibly rich data set. People can use this exact kind of imagery to track deforestation, monitor how our cities are growing, or, as we're about to see, completely change something as basic as how we grow our food.
You know, one of the most incredible things we're doing with all this downstream data is tackling one of humanity's oldest, most fundamental challenges: food security. This number, wow. It's a tough one to look at. According to projections from the UN, this is how many people could still be facing hunger by 2030. That's pretty much the same numbers when these global goals were first set. The scale of the challenge is just immense.
But, and this is a big but, here's where there's some real hope. Technology, and specifically these Earth observation satellites, are giving us a power we've never had before to monitor and manage our planet's farms and resources. We literally have an eye in the sky helping us out on the ground.
So, what does that actually look like in practice?
Well, satellite data makes something called precision agriculture possible. Farmers can see with incredible detail which parts of their fields need more water or fertilizer. That means less waste and bigger harvests. And on a bigger scale, governments and aid groups can track crop health across entire countries, predict food shortages, and give early warnings for disasters like floods or droughts. It helps get aid where it needs to go, faster.
Okay, so we've got this amazing technology, right? It's vital for our economy. It's helping us solve huge global problems. But that brings us right back to the central question. How fragile is it? Because the threats today have evolved way beyond little tin whiskers.
Today, the main threats are deliberate, and they come in two flavors. Jamming is just brute force. It's like someone turning on a giant noise machine right next to you while you're trying to listen to a whisper. It just drowns out the real signal. Spoofing, though, that's way sneakier. It's not about noise, it's about lies. It sends fake but very believable signals to your receiver that can slowly and dangerously trick a ship, a drone, or even a passenger plane into thinking it's somewhere it's not. And let me tell you, this is not some what-if scenario. Look at these numbers from the aviation world. They're just staggering. In just 10 months of 2024, the number of logged spoofing incidents shot up to almost 1,000. That is a massive jump from the year before. This is happening right now, especially in conflict zones, and it's a huge risk to air travel.
And if you're wondering why these signals are so easy to mess with, this quote just nails it. It says, "A satellite signal has about the same power as a 25-watt light bulb viewed from 10,000 miles away." I mean, think about that. The signals we depend on for so much are incredibly, incredibly faint by the time they reach us. They're just a whisper from space. So it really doesn't take much power at all to scream over them with a jammer on the ground. So we've laid out the problem pretty clearly, right? We're super dependent on a system that's facing some serious and growing threats. The billion-dollar question now is, what are we doing about it? How do we make this critical network tougher? For the longest time, the backup plan was pretty old school. It relied on things like inertial systems that use gyroscopes, but they tend to drift over time. And there were also ground-based radio beacons. They worked, kinda, but today's solutions, they're a whole different ballgame. They're much smarter, with advanced algorithms that can actually detect jamming, receivers that can listen to multiple satellite systems at once, like GPS and Galileo, and even ways for civilian aircraft to use the tougher, encrypted military signals. And this really points to a huge shift in thinking. The goal isn't just to have a safety net anymore. It's to build a system so resilient that it provides uninterrupted navigation. It's about blending all these different signals and sensors together so you always have a trusted position, even if you're under attack. The keyword is continuity, not just recovery. Which brings us to the final, lingering question. We are in this constant race between our ever-growing reliance on this incredible yet fragile technology and our ability to protect it from some very real and growing threats. We've come a long, long way from the day the pagers died, but the stakes now are just infinitely higher. It really makes you wonder, are we building our defenses fast enough?